This is part of the concept of Surds. So let's make that. So this is going to be, let's suppose I've got 5 root 14 times root 12. Without using a calculator, simplify the following. You can use the square root button to insert the root or radical symbol. All right, so if I want to simplify this, let's say as far as possible without a calculator, in this part over here, I could break this up into factors of, let's say, 7 and 2, and then put a root over each one, because 7 times 2 is 14. It's like saying 7 times 2 to the power of half is 7 to the power of half times 2 to the power of half. Okay. And then on this side here, I've got the square root of 4 times 3, which can become the square root of 4 times the square root of 3. All right, if I look at all of that and I want to simplify it, I'm going to bring it into a single root with a number in front. This is going to be 2 root 3. This is root 7 root 2. I might not need it, but if I could get a root 2 out of here, it would have taken that out. I could have used root 2 and root 6, for example. All right, but 4 is a perfect square, so that becomes 2. And then when I multiply those two, 5 and 2, I get 10. And I'm done. I've got this extra root 7, root 2, and root 3, which I can't do much with, so I might as well bring that back into a bracket. 7 times 2 is 14, and 14 times 3 is 42. 42 is also 7 times 6, 14 times 3, 21 times 2. But either way, I can't simplify that unless I put it in a calculator or something like that. All right, let's go to another example. So I want to bring it into a number and a root. So let's say if I got 4 root 10 times 4 root 10. 4 times 4 is 16. And root 10 times root 10 is going to be just 10. That's like saying 10 to the power of a half times 10 to the power of a half is 10 to the power of 1. 16 times 10 is 160. So that one's pretty simple, right? If I got cube root of 10 cubed, that's like saying cube root of 10 times the cube root of 10 times the cube root of 10, which is actually 10 to the power of 1 over 3 times 10 to the power of 1 over 3 times 10 to the power of 1 over 3, which is actually 10 to the power of 3 over 3, which is 10 to the power of 1, which is 10. Okay. If I've got 5 root 5 squared, then I'm technically multiplying it 5 root 5 times 5 root 5 by itself. 5 times 5 is 25, and root 5 times root 5 is 5. 25 times 5 is 125. Okay, cool. Let's have a look at the next level. Suppose I've got now root 8 plus root 32. This is the same as 4 times 2, which is root 4 root 2, which is actually 2 root 2. This is 16 times 2, and that's root 16 root 2, which is actually 4 root 2. 2 plus 4 is 6, so this becomes 6 root 2. And I'm done. But if I've got a big number like 252 plus 448, and what you notice before we continue, this is actually like x. This is like 2x plus 4x equals 6x kind of scenario. For this one here, 252, I've got to maybe grab a calculator to break this up into perfect squares. Now I can start with 4. All right, so let's go 4 times the number. So 252 divided by 4 is 63. And 63 is 9 times 7. So that's square root of 4, square root of 9, square root of 7, which is 2 times 3 root 7, which is 6 root 7. And then we got the square root of 448. So 448 divided by 2 is 224. Let's say 448 divided by 4. So this is going to be 4 times 112. But now 112, we're saying we can break that up into something else. So let's say 112 divided by 4 is 28. So 4 times 28. But then 28 is 4. That's 7 times 4, right? So at the end, I can go square root 4, square root 4, square root 4, square root 7. That'll be 2 times 2 times 2, which is actually 8 root 7. And then these two will add up to become 8 plus 6 is 14 root 7. And that's the final answer there. And this is for level 4.